Hola, ¿qué tal? Muy buenos días. Nuevamente, pues nos vemos en este pues gran evento que es el octavo Congreso Internacional de Economía, que pues año con año se ha realizado en nuestra Facultad de Estudios Superiores Aragón. El día de hoy iniciamos nuestras actividades propiamente relacionadas con la exposición de algunas ponencias, pero principalmente con la presencia de grandes académicos y que estarán impartiendo algunas conferencias, pues yo diría magistrales, ¿verdad? Aunque generalmente solamente se habla de la primera y de la última, pero la verdad es que pues prácticamente todas las intervenciones que tendremos en este Congreso merecerían ese calificativo. Y no hay una mejor manera de iniciar estas actividades que con la presencia de nuestro estimado colega, el doctor Steve King de la Kingston University of London. Eh, Steve, welcome to Mexico one more time. Y bueno, pues esta conferencia será grabada y será subida a las redes y al YouTube para que todos aquellos que estén interesados en ello pues puedan consultarla. De antemano, bienvenidos y pues esperamos que disfruten esta conferencia. Los dejamos con los controles con el doctor Darío Ibarra Zavala, quien pues hará las veces de moderador y pues preguntador, ¿verdad? Aquí con nuestro invitado. Así que mucho éxito y comenzamos, por favor.
Muchas gracias. Bien, seré muy breve, por lo menos lo intentaré. Steve King ya ha tenido varias intervenciones dentro de este Congreso de la FES Aragón en años previos. De hecho, hubo eh, un evento importante en donde lo invitamos para la presentación de un libro que voy a poner en pantalla, concretamente la versión en español de Desenmascarando la Economía, Debunking Economics, la versión en español. Es un libro que le trajo fama internacional, además de otros artículos, otros trabajos, en donde fue muy probablemente el economista que mejor describió y percibió la crisis económica que se avecinaba. Estamos hablando de la crisis económica de 2008. Para más detalles de la trayectoria, de la interesante trayectoria de Steve, es conveniente revisar la página web de Wikipedia. Ya existe Steve King en Wikipedia. Por aquí se puede ver parte de su trabajo. Vale señalar que su enfoque es totalmente antineoclásico, es un crítico, posiblemente el crítico que mejor ha sistematizado, válgame la redundancia, las críticas a la escuela económica neoclásica a través de su trabajo, y su enfoque se encuentra desde la perspectiva de economistas como Hermann Minsky, F. Fisher, Keynes y otros. Parte de lo que se ha venido comentando, de lo que Steve ha trabajado, es la crítica de del enfoque macroeconómico que parte desde el enfoque microeconómico. Al respecto, hace un tiempo mis alumnos prepararon este meme, micro, I am your father, macro, no. Es parte de la crítica que hace Steve y que seguramente en la conferencia de hoy se nos estará comentando. Así es que, sin mayor preámbulo, yo los dejo con Steve para que puedan disfrutar de su conferencia. Okay, Steve, thanks a lot. I have introduced your briefly, shortly, your career, so please you can start with your speech right now. I will be here for any. You we can all listen you. Your
Thank you, sir.
microphone.
Thank you, Dario. So put it back on again. So thank you, Dario. Thank you for the invitation and both the invitation and the introduction. So I'm just checking. You can see my screen with my presentation slides there. I hope you can see that.
Yes, we can do.
Uh,
We can see that.
okay, good. All right. Okay. So, of course, when you introduced my book, Debunking Economics, which you translated so well for me, of course, a major emphasis there was critiquing neoclassical economics. But now I think we need to rebuild it. We've got to start with a different foundation completely. And those are my well, 3 books and 2 cartoon books up the top there, but in the right-hand side, and when I send this to you after the talk, that is my next manuscript embedded in the presentation. So that's available for anybody who downloads the slides. And we need to get away from the delusion that you showed so beautifully there that, you know, Darth Vader is the father of Luke Skywalker, micro is the father of macro. No, micro is where the problems begin. So you have this insistence by neoclassicals that we have to build macro from microeconomic foundations. And this is what dynamic stochastic general equilibrium models were actually based on. They was tried to derive macro from the idea of utility maximizing consumers and profit maximizing firms. Now, if they were right, they would have seen the financial crisis coming, which of course they did not. But even though they failed abjectly at that major challenge, neoclassicals themselves still can't see any other way to proceed. So this is Olivier Blanchard, who was chief economist of the IMF for almost a decade, and talking after the financial crisis, saying, well, it is a sensible thing to find a widely accepted analytic core for macroeconomics. And then he said, therefore, starting from explicit micro foundations is clearly essential. Where else to start from? And then on we go there that ad hoc equations won't do, and I agree with that. And he then said, thinking in terms of a set of distortions to a competitive economy implies a long slog, very hard logical derivation to get to a plausible description of the economy. But where else can you start from? Well, the answer is you can start from macro. You don't need micro, and neoclassical micro is wrong anyway. But this is something which scientists became aware of almost, well, actually more than half a century ago. That the fact that the reductionism, which has been the basis of science for so long, taking a problem and breaking it down into its individual constituents to understand that problem, that does not imply constructionism, as Anderson says here. The ability to reduce everything to fundamental laws does not mean the ability to start from those laws and reconstruct the universe. And if that's what economists are trying to do. So he said that psychology is not applied biology, and nor is biology applied chemistry, and equally macroeconomics is not applied micro. It's just a mistake to do it that way. And I've only recently realized that with the work that I've been doing for 40 years now, building models of complex systems based on Minsky's financial instability hypothesis and Goodwin's growth cycle model, they can actually be derived, and I'll show now in a lecture, from definitions of macroeconomics. In other words, we don't need micro in any form at all, whether it's correct or wrong. We can start from macroeconomic definitions itself. And all the micro foundations work has been a pointless waste of time. It's valid to say you want to have sound foundations. What they're doing is violating scientific logic in the way that they're going about it. So if you work from continuous time dynamics, and I'll show that in a moment, you can turn macroeconomic definitions into foundational macroeconomic models. Now, if you agree with the definitions, in a sense, you've got to agree with the results of turning those into dynamic statements and then simulating them. And what you get is not neoclassical equilibrium, you get a complex systems view of how the economy operates. So I'm going to start from an obvious definition, the employment rate. I use lambda, the Greek letter L, for it. That's the number of people with a job divided by population. You can't disagree with that. The wages share of GDP, that's wages divided by GDP. Again, that's a definition you can't argue with. And the debt ratio, which is what I've added to my own work, has been on the role of private debt in capitalism. And then government spending. So net government spending and excessive taxation is what we call the deficit divided by GDP. So you start from those definitions. And what I employ to turn these into macroeconomic models is the simple rules of logarithmic differentiation, that if you have 1 over x dx dt, and the symbol that mathematicians use for that is x hat, then x divided by y hat is x hat minus y hat, one of the rules of the logarithmic multiplication and division, and x hat times y hat is x hat plus y hat. Very simple rules. Now, with those rules and a set of simple definitions, I can derive a totally different but realistic vision of macro compared to what neoclassicals have. So the definitions I'm going to use here, and I try to use text in such a way that the meaning is obvious for the parameter itself. KYR is the capital output ratio, and we treat that as a constant. Delta KD is the rate of change of capital due to depreciation. So all the terms I'm using here, I hope, are self-explanatory when you see the equations turn up. I'm going to do a bit of fast derivation now, which maybe a bit overwhelming for people who aren't used to thinking this way, but it's just to show how really simple this process is. So you start from the employment rate, you then break that down into the rate of change of labor minus the rate of change of population, and then the dynamic statement of that definition, which is the ratio of employment to population. The dynamic statement of that is the employment rate will rise if employment grows faster than population. That's simply a fact. Okay? Equally, the wages share of GDP. The wages share will rise if total wages grow faster than GDP. That's another fact. So you can take those and then do the substitutions using the terms I showed on the previous slide to turn those definitions into dynamic models once you make a set of assumptions that tie those two variables together, the wages share of GDP and the employment rate. So I'm starting from saying I've broken this down to the logical statement, but now I substitute that our output divided by labor is the output to labor ratio. So I can replace L here with output divided by the output to labor ratio. And I can divide the rate of change of population with an assumption that population grows at a constant rate, delta N. So I've now done that. And again, I've got another expression involving a hat statement. So I can now say y divided by YLR hat is y hat minus YLR hat. That then I can then working from a fixed capital output ratio, and I'm happy to defend why that's a sensible assumption in any questions afterwards. I can now substitute the rate of change of output here is the rate of change of capital. And the rate of change of capital, of course, is the rate of investment. So I now show the rate of change of output, which is this expression in this equation, is equal to gross investment divided by the capital stock minus depreciation. If I assume, and this is what Goodwin did when he first built his growth cycle model back in 1967, you assume that capitalists invest all their profits. That then gives you that the rate of change of output is 1 minus the wages share divided by the capital output ratio. And I'm using V there, pardon me, rather than KLR. That's my mistaken notation, minus the rate of change of depreciation. So I finally end up with an expression saying the rate of change of the employment rate is the wages share of GDP, 1 minus the wages share of GDP, divided by the capital output ratio, minus depreciation, minus change in the output to labor ratio, minus population. Now I do a similar thing, and I'll go through rather more quickly because I don't want to get caught up just in notation. You can all work through this later yourselves. A similar expression for the rate of change of wages share of GDP brings you down to saying that the rate of change of the wages share of GDP is effectively the Phillips curve minus the rate of change of labor productivity. So you get a basic dynamic model, which is stated there, and this is all working from definitions, remember. I haven't started from an obscure set of assumptions. I've started from definitions nobody can disagree with. And what I've got is a set of differential equations. Now, when I simulate those differential equations, what I get is Goodwin's growth cycle. This is something which is built by Goodwin back in 1967. And that, therefore, from my point of view, says that Goodwin's model and not Ramsey's growth model, which is what neoclassicals use, that is the true foundation for macroeconomics. And it's inherently cyclical. The equilibrium is not it's not unstable, but it's not an attractor either. So when you put this together mathematically, what you get is a system that goes through permanent cycles. And that's what we've seen in the real world. The system is cyclical. So I started from equilibrium, I gave the system a shock, and now it continuously cycles. And that's the basis. Capitalism is cyclical. This is the first insight. So a very first model in macroeconomics gives us a system which is cyclical rather than one that reaches equilibrium. Now, when you add debt to this model, this is the private debt ratio, what I get is Minsky's financial instability hypothesis. So, and Minsky had the insight to say that the debt plays a fundamental role, private debt plays a fundamental role in the capitalist system, both enabling the expansion of investment, but also causing potential breakdown. So his verbal, what I did when I first built my model of Minsky was take this statement and turn it into a model. In fact, you can do it by working from strictly true definitions. So I've done that. I've done it, not explaining it here. But when I do this, what I got out of Minsky by my mathematically modeling Minsky was something Minsky himself didn't see. And you can see that the cycles of the employment rate there are getting smaller. The wages share of GDP is falling. these are emergent properties. These are not things that are defined into the model, but they're part of the overall dynamics of the model. And I explain them in detail in that new book I embedded in the first slide of the presentation. So what you get fundamentally is what you get the great moderation followed by a crisis. Now I can bring in prices in a similar way. When I bring in prices, I got what I call Fisher's paradox coming from his definition of the Great Depression. But the more people borrow, the more they owe, or rather, the more they repay debt, the more they owe, because they have a falling price level feeding into the system. So here's a system including price dynamics as well. And it looks like everything is reaching, reasonable stability, a falling rate of prices. That, according to neoclassical, should be a good thing. Looks like the system is stable, and then keep on going for a while, and deflation increases the real debt burden. And at some point, almost without warning, the whole system collapses. You can see the final graph on the bottom level there. The real economic rate of economic growth is quite stable. A neoclassical might mistake that for equilibrium. They ignore the private debt level, and then look what happens. The system falls apart. That is the deflationary side of debt deflation. And Fisher saw this in his attempt to explain where the Great Depression came from. That as people start paying off their debt, they liquidate to try to make it easier to bring customers in through their door rather than their rivals. They reduce their prices. Everybody does the same thing. That actually increases the real burden of debt, even as people pay the debt level down. And then you have a debt deflationary crisis. And that's what we saw in the Great Depression. This comes out of a natural definitional based version of economics, which is why I see this method as so powerful. Now, what about bringing in government? What you get with government is what mathematicians call persistence. So rather than reaching equilibrium, and again, this is a mistake for neoclassicals to believe that everything reaches equilibrium. What true stability in a capitalist economy is not the absence of cycles, but the absence of cycles lead to economic breakdown. And so when I put together my model of the government sector as well, back in 1992, what I got was a form of what you might call modern monetary theory, that government spending prevented you from falling into a debt deflationary trap. So this is a government that spends sufficiently to effectively creates money to stimulate an economy which otherwise fall into a debt crisis. You have the outcome like I'll show on this chart here, where the system doesn't reach equilibrium, but it doesn't break down. You get persistent cycles. And that's what we've seen in capitalism for its history. This is what a complex system vision gives you of the system. So the obsession with equilibrium that neoclassicals have made is not only a wrong way to characterize capitalism, it blinded them to this sorts of dynamics. They try to explain this using exogenous shocks. There are no exogenous shocks in this model. It's all endogenous dynamics. Oh, pardon, I pressed the B key there. So this is, showing you can get a decent macro without going anywhere near micro. But that's not to leave micro alone. A major focus in my debunking economics was to say how irrelevant micro and how wrong it is. And when you look at how people are taught about the demand curve, you're given a way of deriving an individual demand curve in a typical neoclassical textbook, and then the textbook author will wave their hands and say, let's derive the market demand curve. And this is what happens with Samuelson and Nordhaus's own text. They say we've derived the individual demand curve. What about the market demand curve? Does it obey the law of downward sloping demand? It certainly does. That is absolutely a lie, quite mendacious, because when you look back and see how Samuelson proved this situation, he made the most crazy assumptions, I think, in history. First of all, he acknowledged that when you derive an individual demand curve, you are not changing incomes by changing prices when you derive the individual demand curve. But when you do the market demand curve, when you change prices, you must also change incomes. And therefore, there's no way to do that without affecting the distribution of income. And when you do that, the pivot point on the standard individual curve moves. When you add up all those moves, you can get any shape at all. The only way you can avoid that is where you have a world in which tastes are identical, not only for all men, but also for all men, whether they are rich or poor. Now, that is a contradiction. Basically, that's proof by contradiction. You cannot derive a market demand curve that has the characteristics of an individual demand curve. not taught in any particular textbook. And then when mathematical economists took a look at the same idea about 20 years after Samuelson, they reached the same point of view. They said the utility hypothesis tells us nothing about market demand. So all that work you do about individual demand curves, utility maximizing, budget constraints, and so on, you cannot derive macro from that. You can't even derive the individual market from that element. So there's a huge mendaciousness to textbook writing, not because they think people want to lie, but because they wanted this to be true. And when they proved that it wasn't, they couldn't cope with it, and they made various nonsense assumptions to try to get back and justify their way of thinking. When in fact, when you look at it properly, you cannot derive a market demand curve, let alone an aggregate demand curve, from the idea of a utility maximizing consumer. Now, equally, when you look at supply, you get the idea of rising marginal cost because of diminishing marginal productivity. This is from Alan Blinder's research in 1998, when doing a survey of about 7% of American GDP, corporations representing 7% of America's GDP. He said the overwhelmingly bad news is that only 11% of GDP is produced under conditions of rising marginal cost. And what he did was he surveyed a large number of firms, and he found most of them reported constant marginal costs. Almost the same scale reported decreasing marginal costs, and only a handful reported increasing marginal costs. And I think that's actually optimistic, because Blinder did not want to find this result. He had standard neoclassical PhDs helping him ask the questions. I think there was interviewer bias. The numbers are worse for the theory than was found here by Blinder. You can certainly find that in earlier surveys, for example, with Eitman and Guthrie, where they surveyed 1,000 firms sent out at random, got about 1/3 of the firms to reply. And what they gave them were these curves to say, which of these curves fits the actual structure of your costs? Now, of those curves, the only one that really fits the neoclassical vision is number 3. That's what it looks like being in your textbooks. That's the neoclassical vision. And that got 0. Okay? No firms, one company, but no product managers said that was what their cost curves looked like. For all the remainder, it's barely neoclassical. That got, again, 3 firms, but again, no product managers. That one only at a pinch. These ones are what you get from empirical research and Raffer's analysis and Koleski as well. And that's by far the majority. That's 95% or more of the firms that produce reporting. They have constant or falling marginal costs. So the entire theory of the supply curve that you get taught in textbooks is also wrong. And when you look at the real world research, what you find is a cost structure like this. This is from Andrews back at the end of the Second World, the early post-World War II period. And he said, this is what we found. Average costs, or what he calls average direct costs, so the variable cost per unit, are constant or falling. Overhead costs, of course, average cost decline as a rectangular hyperbola. There's a firm's, the planned output they want to get, and the plant capacity itself. That's the sort of structure that actually exists in the real world. So when what happens when you try to mathematically model that? And Anderson was just flummoxed. In 1949, this hadn't been accepted until almost a century later. We're still teaching nonsense, which contradicts this. So there's something very, very wrong about how economists have approached this particular issue. So why are marginal costs constant or falling? Well, this was explained by Altman and Guthrie back in the 50s. And they said factories are designed by engineers, and engineers design them so they reach maximum efficiency at capacity or very near capacity. So when you derive a short-run marginal cost curve from that, it's going to be constant or falling, and marginal costs will be below average costs at all levels of operation. So what you therefore get is profits will rise out to capacity. And putting this mathematically, the profit of a firm is going to be its price multiplied by the quantity sold, minus the variable cost times the number of units, minus fixed costs. Now, if you differentiate that with respect to quantity, you find that price minus variable cost is always positive. You don't get a point where the rate of change of profit is 0. And if you look at profit per unit, so you divide through by Q on both sides here, and then you take your differential for that, you find profit per unit is equal to fixed cost divided by quantity squared, which is also greater than 0. So the more units you sell, the more profit you make per unit. So as fixed costs per units fall, you have an identical rise in the level of profits because fixed costs per unit have fallen. So, and also this whole myth that we have in our heads of industries consisting of homogeneous products, all being sold at some, an idea of a market price for all these homogeneous products, that's nonsense. The products we see are differentiated. There is no such thing as a car, okay? There is no such thing as an equilibrium price for a car. There are numerous different cars with differentiated features sold to differentiated parts of the market where the producers settle list price and they do not verge particularly far from that list price. So when you take a look at that structure, this is now putting some mathematics in the graphical form on Andrew's vision. If you have a target level of output here, and you exceed a higher level, then you're going to get a higher profit. Okay? Profit rises per unit and in the aggregate as you increase scale. So what we see in the real world is true profit maximization behavior. Firms sell as many units as they can, and most of the sales that they make come at the expense of their competitors. That's real competitive behavior. So that's neoclassical microeconomics, which they think is the foundation for a science of economics, is not scientific, it's mythical. Now, what happens when we throw away the vision of equilibrium, which has become such a organizing concept for neoclassical economists? Well, simple, we use what's called system dynamics. And rather than ceteris paribus, all other things remaining equal, in system dynamics, everything affects everything else, but you have all the feedbacks that are involved in that system. So it's hard for non-experts to follow in many ways. But this idea of system dynamics is shown here. So I'm now showing a similar model that I had earlier to Minsky's financial stability hypothesis model, but I have a causal chain. So output divided by an output labor ratio gives you the number of work divided by population gives the employment rate. Feed that into a wage change function down here, you get the rate of change of wages. Multiply that by the wage rate, integrate it, you get the wage, times labor, you get wages, etc., etc. I've got a causal process here, and everything affects everything else, and I can still analyze the system. So that's the type of approach we should be using, and that's why I invented the software package Ravel. It's system dynamics for economists, and you can do modular design of a system. You can design different components and bring it all together, and there's extremely sophisticated work being done now to build dynamic versions of alternatives to dynamic stochastic general equilibrium models using Minsky. So I'd encourage people to have a look at that type of work. And the scale is enormous. So this is a draft model by a colleague of mine, actually with the last name of Keynes, Tyrone Keynes. And that is quite a complex systems model of a capitalist economy involving the biosphere as well as involving the domestic economy. So there's no limit to the scale of sophistication of the models you can build using this system. And again, I've embedded these models inside the presentation. So if you want to take a look at them after my talk, you can download the slides and take a look at them. Now, we've had a whole theory saying we shouldn't consider money. Money is ignored. Money is a veil over barter. That is also wrong. Money has real effects. And the way that I illustrate this is using a device I call a Moore table, named after Basil Moore, the great monetary theorist. And that shows expenditure on the horizontal axis and income on the vertical. So households are spending A dollars per year on services and B dollars per year in manufacturing, and necessarily that row sums to zero. You have services spending C dollars per year on on the households, and D dollars per manufacturing. So you get the idea that everything sums to zero, and what you get out of this is the expenditure sums to zero, but income can be greater or less than zero. Okay, but the whole table necessarily sums to zero. This is why we work in terms of gross rather than net expenditure in macroeconomics. But the negative of the sum of the diagonal is aggregate expenditure. So you take up the sum over there, you get minus A minus B, etc., etc. Take the negative of that, that's aggregate expenditure. And the sum of the off diagonals, this lot, okay, that is aggregate income. The two are necessarily equal. So this is the foundation point of showing the role of credit in aggregate demand. This is a model without credit of any form, but what you get is aggregate expenditure must be equal to aggregate income. Now, if I apply this to loanable funds, which is the textbook model of banking, that is where one sector of the economy lends to another sector. So what I'm showing here is the services sector lending to the household sector, and then the household sector paying interest to the services sector on the outstanding level of debt. And when you do the same sums that I'm showing there, there's the transfer of credit. What you get is that credit cancels out, because the service sector is lending credit dollars per year this way. It therefore spends credit dollars less in the opposite direction. So credit cancels out. So you do your aggregate sums as I did for the previous table, and credit disappears, but interest does not. Interest appears only once on the diagonal and once on the off diagonal. So under loanable funds, interest payments are part of aggregate expenditure and aggregate income. So that's just showing how this applies to the textbook model of the real world. Now, credit disappears, and this is consistent with neoclassical thought. But of course, this is the model of loanable funds, which is a fallacy. The Bank of England said so in 2014, the Bundesbank in 2017. I'm part of a long tradition of non-neoclassical economists saying banks create money when they lend. So you need to now take a look at what I call bank-originated money and debt. And here, if you borrow money, households borrow money from the banking sector, the debt they owe to the banking sector goes up at credit dollars per year, and they get credit dollars per year for borrowing, which they then spend, and then they pay interest to the banks. You put that together and work out what the overall dynamics are. There's the extension of credit. There's the borrower spending that credit. Nobody borrows for the sheer pleasure of being in debt, so you borrow to spend. But credit, therefore, does not cancel out. When you add up the aggregate expenditure on the diagonal and aggregate income on the off diagonal, you find credit turns up in the system. So what that means is credit is part of aggregate demand and aggregate income. So our modern macroeconomics must be monetary, and the monetary system plays a vital role in causing both economic growth and economic slumps. And when you look at the data is overwhelming that this is the real world. This is a regression of credit as a percentage of GDP versus unemployment as a percentage of the workforce for America between 1990 and 2014. The R-squared is ridiculous. The tightness of the correlation is ridiculous, in the point that this is what neoclassical theory says doesn't apply, and the data incredibly strongly contradicts neoclassical theory. So we need to be able to think in a monetary sense. And that's one reason I invented Ravel as well, because Ravel enables monetary modeling. That's, by the way, a link if you want to get a copy of Ravel. We now charge a small amount of money for it. You can download it from that link. And why it enables you to do monetary modeling is because it includes a component that I call a godly table, which enables you to do modeling of financial dynamics using double entry bookkeeping. And this enables you to do sort of thought experiments and say, what would have happened if policy was different at some point in time? So this is a model of America during the 1920s, set up to suit to reproduce Calvin Coolidge's running of surpluses. And I show that Calvin Coolidge thought his surplus caused the 1920s. But if you have his surplus without credit being created at the same time, you actually get a slump. So you can differentiate and say, well, let's look at credit on and credit off and see what the impact was. So it's an incredibly useful tool for analyzing past economic data and also for saying what government policy should be. I've got a lot of points here, so I'm going to stop with this particular one, which is the role of energy in production and the failure of conventional economists to get any awareness of this. Now, I solved that problem with this little insight back in 2019, that what is the role of energy in production? Well, it's obviously that labor can't work without energy and machines can't perform without energy. So a worker without energy is a corpse. A machine without energy is a sculpture. And therefore, energy is an input into production without which work can't be achieved. Pardon me, pressing the B curve there again. And when you look at the data is incredibly strong in favor of the proposition that fundamentally GDP is effectively energy turned into useful work. So the left-hand chart shows you GDP on one axis and energy on the other. The right-hand one shows you the change in the two on the same scale at the global level. They are incredibly tightly linked. The correlation of change in energy and change in GDP is 0.83. The correlation of the two together, because they're rising, is even higher. So this actually shows that the Leontief production function, which is what I used for the fixed capital output ratio earlier, that is empirically superior to what neoclassicals use. And the reason it's superior is neoclassicals think the fact that the Cobb-Douglas production function allows for substitution is really good, but there is no substitute for energy. If you don't have energy, if you don't have petrol in your car, you can't put chocolate in there and get the car to go forward. Okay? Energy is absolutely vital. There is no substitute for energy. So what you then get is what we call the capital output ratio, is actually the inverse of the efficiency with which machinery turns energy into useful work. And that's what we should be doing. That's the realistic way of modeling the role of energy in production, is to say that energy, that machines enable us to convert energy input into useful work, which then takes the form of commodities. So that explains this incredible one-for-one relationship between change in energy and change in GDP, or change in global world product. And it's therefore possible to build models of the economy, again, this is done in Ravel, that tie together energy consumption, resource depletion, pollution, and so on. And this shows the potential for a crisis with simply resource depletion in this particular case. So we can model this work. We don't lose the capacity to model. What we get rid of is the mistake of trying to model the economy as if it's an equilibrium. So we need to integrate the macroeconomics with ecology at a fundamental level, and that starts from seeing gross world product, or energy, is fundamentally energy converted into useful work. And this is why neoclassical economists have also made the greatest mistake in the history of humanity, that is misunderstanding climate change. Because without knowing the role of energy in the production, they can make stupid, that's the only word I can use for it, stupid statements like this by Nordhaus back in 1991, that it's really hard to find any impact of global warming upon these industries, manufacturing, mining, etc., etc. That's nonsense, because we're causing global warming by generating energy using fossil fuels or extracting energy from fossil fuels. That's obviously what's causing global warming. Of course, if we address that problem, we are going to change what we can produce. So it is completely fallacious foundations of their analysis of global warming. And that's led, I think, neoclassical economists to set us up for the destruction of civilization. I really do believe civilization is going to fall apart in the next 20 years. And that'll be because we've completely ignored the impact that global warming has upon our productive system. And I have to say that the work that neoclassicals have done on this front is the worst I've ever seen. And I've written this up in a report for a group called Carbon Tracker, a report called Loading the Dice Against Pensions. And this is a journalist's survey of that particular work. And he used the summary to say that what you see with climate science, with economists doing work on climate science, they're basically idiot savants. They have no idea of what they're doing, and they've made stupid mistakes which are going to jeopardize the potential survival of civilization. And you can see this particularly when you contrast how economists talk about tipping points versus what scientists do. So this is a paper by economists saying that losing the losing the Arctic summer sea ice, Greenland, the West Antarctic, the Atlantic, the Amazon basin, the Atlantic meridional overturning circulation, permafrost, and ocean methane hydrates, things which will be make the planet visibly different from outer space, will only have a trivial impact upon the economy. Whereas you look at scientists, they're saying it's impossible to reconcile this trivial estimation of the damages from climate change to what economists are talking about. Now, they wrote back to us and said, well, strange, you seem to think that there's damages from tipping points are going to be larger than we said. Well, they are basically saying that these losing those enormous parts of the planet, making the planet visibly different from outer space, would have no impact upon the economy. That is just insane. And scientists themselves are saying there's a huge gap between how scientists talk about tipping points and how economists do. And it's the ignorance of economists that lies behind it, not any wisdom by economists on that behalf. Now, part of the reason for this happening is the fact that academics in general, not just economists, work in intellectual silos. One group doesn't read what the other group does. But this is a cross-disciplinary area where we simply have to get the science right, or we're jeopardizing the survival of our civilization, and we haven't done that. So one of the best examples is what's called the thermohaline circulation, the huge ocean conveyor belt, as it's called, that transfers heat and cold around the planet with an enormous volume of water passing 30 times the volume of all the waters and the rivers in the planet are passed around by the thermohaline circulation. And part of that's called the AMOC, the Atlantic Meridional Overturning Circulation. And that keeps Europe between 3 and 8 degrees warmer on average than it would be in the absence of it existing. That's one of the tipping points which should be turned off by the melting of Greenland. So that's the actual design, that's the actual shape of the system. There's heat release up here, and that makes Europe in general 3 to 8 degrees warmer than it would be without the AMOC, and makes Norway 40 degrees warmer than it would be. So if that disappears, if that actually turns off, and we're seeing strong evidence that it will, economists say it's going to boost the economy. This is a paper from 2016 by 3 economists. They think it's going to increase GDP, whereas scientists have said it would have a critical challenge to food security, would have a catastrophic impact upon civilization. Now, the scientists know what they're talking about. The economists do not. But we're being set up for this enormous plunge. And I might actually, I know that I'm taking up a lot of time here. We should actually have some conversation rather than me talking all the way through. So I'm just going to quickly bring my slides up and show these. Pardon me if I've got a recording. I better stop recording that. I'll just bring the slides up and show them properly, and just let you take a look at the slides at a later point. I'm trying to move that down here. So if I take a look at where the Gulf comes from, first of all, when economists read scientists, they see what they want to see. This is showing how strongly Nordhaus's arguments about what climate scientists said actually contradicts what the climate scientists have to say. They've used methods which simply don't make any sense. This is one where they try to, where the economists assume that 87% of the economy will be unaffected by climate change. Why? Because it happens under a roof. That is mistaking weather for climate. That is just so wrong. They believe that they can use data across space. In other words, current geographic and data about temperature and GDP to predict the impact of climate change. That is simply nonsense. Okay? They have extrapolated across tipping points. So here we have a survey finding a nonlinear relationship between temperature and GDP between 1960 and 2014, and then extrapolating that across 5 degrees of global warming. That takes it across tipping points. Those are structural breaks. You cannot use this data to extrapolate across that data unless climate change doesn't change the climate, which is crazy, but that's what's necessary. They use quadratics for damage functions. Y equals x squared is as sophisticated as the damage functions get to be. That is also a farce. And when they survey and say, what do experts think? The only experts they ask are other economists, and they get trivial results from the economists, whereas in this particular case, a survey of economists who published on climate change thought that 7 degrees of warming in 2 centuries' time would reduce global GDP by 20%. Scientists are saying 5 degrees of warming will drive us extinct. This is the gap between scientists and economists right now. They even have made up their own models, which they call integrated assessment models. And those models, when you economists normally say you should specialize what you're good at. Well, economists aren't good at building climate models. That's what they've done. They've used their own models instead, and their models don't even include rainfall or wind. And those are the things which are now doing the most damage at the moment out of climate change. So economists have breached every last one of their own rules in putting this work together. So what I've done is this is a later section I show what happens when you have different data and different predictions. And economists are using the quadratic, This is what happens if you use an exponential or a logistic function. They imagine you can get out to 6 degrees of warming and only have a trivial impact upon the economy. This is saying on the path we're going to wipe the economy out. And that's the seriousness of the situation we face. And I want to finish with just one illustration of why economists got this so wrong, because we've been fooled by the stability of the climate over the last 4,000, 5,000 years. That's the global temperature, not carbon dioxide now, but global temperature from 2,000 years ago into 2023. And that's when the Industrial Revolution began. If you then go further back and say, well, what's the whole span of human civilization? That's it. That is back when the pyramids were built. This is back when Göbekli Tepe, which is the oldest human mesostructure we've discovered in Turkey. That's the entire duration of human civilization. But go back further still, and you find yourself in the Ice Age or the glacial period. That's the last glacial period, and that finished 20,000 years ago. And that was 6 degrees cooler than we are at the moment, roughly speaking. Now, human civilization is that tiny little blip there. Take a further look back and see where does this actually come from? There's what are called Milankovitch cycles that give you booms and busts in the temperature over time. And those are the peaks of those Milankovitch cycles over the last million years. And human civilization evolved on one of those peaks. So what we should have done is maintain that temperature consistently. We only evolved back at that point. We've only been around for a very short period in the planet's history. And we've extrapolated that as if that's absolutely normal all the way through. If you go back further still 2 million years, you see that this period of interglacials and glacials is a very unusual period in the history of the planet. So again, we evolved at an unusual point in time. Go back further enough, and you then see over the last 70 million years, that's when the dinosaurs went extinct. So we have this tiny little point in history, and we haven't realized how fragile it is. We managed to produce civilization because of the moisture level and the stability of the climate in this particular range here. And if we were really very sensible, we would have said, well, let's maintain that temperature and keep it going. That would have been rational. That's what we should have done. We could have got to the Jetsons' future. If we didn't do it, then at some point there would have been a decline. That would have been the natural cycle taking us back into another glacial period. Instead, what we've done is boost the temperature at a rate 30 times faster than the natural cycle. Now, that's not rational. That's suicidal. And that's the path we're currently on. And that's why I think the economists have really set us up for a catastrophe, which this cartoon illustrates. So I'll leave it at that point. Let's have a conversation.
Thank you very much, Steve, for this interesting conference you have give us. There is one question here we have. What about time? ¿Cómo andamos de tiempo, Salvador?
Tenemos hasta 10 minutos.
Okay, perfecto. Okay, we have 10 minutes, 2 questions. Well, the first one, it's from Oscar. The question is, give the continual weakening of the neoclassical model due to its theoretical limitations, how can we challenge this economic approach to pave the way for a new paradigm that seeks equity among all economic agents? That's from Oscar.
I think if we realize that there is an alternative to neoclassical equilibrium thinking, the system dynamics based on definitions, which neoclassicals cannot reject definitions. So if we show that we use a definitional approach and get a completely different vision of the economy from them, that itself is very powerful. And then we can say, well, can we now fit this information to data? And there's a colleague of mine who's, his name is Tyrone Keynes, and he has produced what he called MESSI, MESSI. So take a look at that, search for that and take a look at that model. He's now showing that model has a better capacity to predict events like inflation, unemployment, the impact of interest rates than you get out of the DSG models of the neoclassicals. So this is the alternative paradigm. My presentation of it is to argue that fundamentally this is like going from the Ptolemaic vision of the universe, which are extremely elaborate, very mathematical models fitted to the data, but were completely wrong about the structure of the economy. This is now comparing it to the Copernican models. We might initially be somewhat less accurate because we don't fit the data as tightly as the neoclassicals have done, but in terms of getting the future direction of the economy, these models will be far more realistic. So there is an alternative method. It's system dynamics, and my Ravel software is the foundation that I think economists could use to build that properly.
Thank you very much. I think it will be helpful if you give us the web page from Ravel, so we can see the possibility
Yep,
of downloading.
I'll just bring that up in a moment. It's on Patreon. We may go to a commercial site at some point, but I'll just link it here. Hang on a second. And so that's the site. Yes, there we go. So if you go to that particular site, you can download a copy of Ravel.
Okay, excellent.
Try it out.
Thank you.
I'm
Okay,
happy to come over and give some seminars on it.
good. There are more questions. Next one. What is the perspective in academy, for example, in Australia or Great Britain, regarding the macro on macro approach? Is this approach already taught in universities, or is the classical method still predominant?
It's the neoclassical paradigm is still dominant. They will not let alternatives in. You won't get this being done by the so-called leading universities because they're wedded to the neoclassical paradigm. So it's got to be done by non-orthodox universities. We have to develop despite their resistance. There's no way that neoclassicals are going to abandon their paradigm, but they should have we should have abandoned it 100 years ago. There's so much logical contradiction, which I go through in debunking economics of the paradigm, so many intellectual failures, empirical and logical. It's a failed paradigm that refuses to die. So the only way to get around it is to develop a new paradigm.
Okay, thank you very much. There is another one. In your opinion, how does this new model fit, and how should it be modified in order to apply it into South American countries like Mexico? Thanks.
Okay, you're going to have to, like for example, the Messi model, which I mentioned earlier, is fitted to American data. You'd obviously be fitting your data to Mexican data. That's the first priority. In many ways, the structures remain the same. Every economy has banks, every economy has money, and so on and so forth. But like the American economy can run a trade deficit and not run out of American dollars, whereas any other country running a trade deficit is going to struggle because it's going to have to borrow American dollars to continue trading. So you have limitations like that you have to take into account when you're not the dominant economy on the planet. But it's feasible to take a model like this and get the same dynamics will exist overall. You're still going to have competition between workers and capitalists over the distribution of income. You're still going to have inflation caused by competitive income distribution demands. You're going to have raw material issues. Your raw material, you'll be importing raw materials. Um, all this sort of stuff is feasible to model. It just takes time to do that, and it is quite feasible. You'd also have to look much more at the international trade vulnerability than America does, obviously, but all those things can be done.
Thank you. There is another question. What we can do as economists or as students to create a new economics perspective that enable us to understand in a better way the economic world and to use the economy and economics to truly get a social welfare.
Okay. You have to abandon neoclassical economics. Okay? Just don't even bother with it. It's a waste of time. That's why I've embedded my book, Rebuilding Economics from the Top Down, in the presentation. I'll send it to Dario after the talk. There is an alternative way to build economics. You need to learn what has not been taught in the mainstream courses. So that involves learning people like Marx, but not Marx of the Labour theory of value. I'm critical of that as well, as Dario knows. You need to learn Schumpeter, Minsky, Fisher, Goodwin, all these. There are strands on which we can build an alternative economics, but it fundamentally comes down to using system dynamics. That is the way to handle non-equilibrium situations and feedbacks, and something where rather than ceteris paribus is used, you have everything depends upon everything else, but you tie the feedback effects up to see what the overall dynamics are. So system dynamics is the way to go. And a lot of the good work you'll find being done by non-orthodox economists like Schumpeter, like Fisher, like Minsky, is actually an evolutionary version of system dynamics.
Excellent. Thank you very much. Well, we have no more questions, at least not here. So I will switch to Spanish to give the final word. Muchísimas gracias a todos los que participaron en este evento. Debo señalar que en una conversación privada con Steve, él mencionó su interés por venir a dar este tipo de presentaciones personalmente. Así es que aprovechando la ocasión que hay personas del posgrado, él está dispuesto. Si en el próximo evento esto fuese posible, pues entonces podremos hacer algo con él presencialmente. Muchísimas gracias a todos por participar. Thanks a lot, Steph, for your presentation.
Thank you. You've been invited, and I hope to see you in Mexico again one day.
Okay.
Okay. Bye, everybody.
Bye.
Bye. Thanks a lot.